Thank you for attending today's webcast and welcome. Today we're wrapping up the third in our series, recapping some of the highlights from this customer story series over the years. And today we're focusing on sustainable manufacturing. This has really been an exciting series for us to produce, and we will continue to produce 2 or 3 a year as more educators are teaching courses with results that they're excited to share. And ultimately, every story that we tell is all about how education is integrating environmental sustainability into curriculum, ultimately because it's all about creating a greener product marketplace. So it's all about jobs, and jobs that create the marketplace and the economy that's appropriate for this century. And schools who are with it and are integrating this curriculum into their standard curriculum will continue to attract students who are looking specifically for this kind of education and know that there will be jobs, and ultimately manufacturers will know to recruit out of your schools because they're going to get students that you're preparing for this greener product marketplace. Sustainable Minds is a B2B software solution designed originally for use in industry, but over the years we've seen this adoption in education in all types of curriculum, business schools, every kind of engineering, design, and even now architecture. And because it's a SaaS solution and in the cloud, there's no downloads, there's no challenges to installation, there's no more installing a shared piece of software on computers in labs or libraries. Everybody gets their own subscription, and it's cost effective. And so we've seen pretty wide adoption around the world, even in places we couldn't have imagined. We get excited when we get a new dot on the map. This is one that we happen to like a lot, which is the University of Mauritius. And so today we're going to look at a very special series of presentations coming out of the University of California at Berkeley in their mechanical engineering program, as well as their laboratory for manufacturing and sustainability, which they refer to as LMAS. When I went back to review the content from this particular webcast, it became clear that adding St. Louis University to this particular webcast would be too much content and wouldn't be appropriate to give the time to each. So we'll do a special webcast in August featuring 3 mechanical engineering faculty and their respective courses, and you can watch for the St. Louis University story then. So today we're going to focus on Dave Dornfeld and what Dave created at UC Berkeley. Dave was the chairman of the mechanical engineering school at UC Berkeley, and one of the projects that he created was LMAS, Laboratory for Sustainable Manufacturing. Dave passed away recently, quite unexpectedly, and has left the school and everyone he touched in a very sad state of affairs. And so it was fitting for us to take this time to revisit the work that Dave did and was doing, and the contribution that he made to us. And in fact, Sustainable Minds software is used widely at UC Berkeley, and it was Dave's intent for it to continue to expand so that ultimately every student in the mechanical engineering school at UC Berkeley will have Sustainable Minds as a tool in their arsenal of tools And I'm going to show you how Dave envisioned the teaching suite of tools and methods, both in the mechanical engineering curriculum and how what was happening in LMAS, that research, how that was being channeled from the lab into the curriculum. When they gave this webcast, this was a very unique presentation because it was kicked off with Dave, the chair and director of the lab, and talking, kind of setting the context and explaining his vision for the school and for the lab. And then following that, Margot Hutchins, who is one of the engineers and lecturers and the associate director of LMAS, talked about the course that she was teaching, and you'll see that there are 3 use cases that we'll go through that she included in her course. And then very uniquely, we also featured Cindy Bailey, who was one of Margot's students and actually was one of Sustainable Minds' early summer interns. And it was Dave who had recommended that she reach out to us, and I have to say that Cindy was one of our very best interns and came back for multiple summers. And so this is a really interesting set of stories with the executive director laying out his vision, Margot showing implementation, and then Cindy from a student's perspective talking about her experience of integrating lifecycle thinking into design and engineering. So what we're going to do today is we're going to go through Dave's presentation and then do a very short overview about Sustainable Minds, the software, and how it's used, and then go into Margot and Cindy's presentation so that you can see and understand their implementation of Sustainable Minds in their curriculum and in the project. As I mentioned, Margot shared 3 projects that were part of the coursework, and then Cindy came along and showed how she had been developing a new project under the context of the lab to be rolled out into the curriculum in the engineering course. So kicking things off with Dave, this is Dave's presentation, and it always starts with a bio. He had been at UC Berkeley for quite some time and started, and this presentation you can see was from 2013, so it's already 3 years ago. He had at that point served as the director of the lab for 7 years. He certainly was well regarded and well respected and quite prolific in his publishing, patent work, and leadership in research, both in manufacturing, sustainable manufacturing, and product development. Some statistics about the School of Mechanical Engineering: 590 undergraduate students, graduate students, faculty, and a lot of staff, so roughly about 1,200 folks in the school. And this is the overview of the breadth of the applications of mechanical engineering, everything from bioengineering to solid mechanics, computation, and lots of things in between. And LMAS, the Laboratory for Manufacturing and Sustainability, again, was a lab to look at how the purpose of any kind of research lab, use research to study particular topics, in this case, the focus on sustainability in manufacturing, to roll it back out into their coursework. And Dave, being a systems thinker, tried to teach sustainable manufacturing, and not tried to teach, did teach sustainable manufacturing from a systems perspective, looking holistically at social impacts, at the outermost ring, and starting with data-driven methodology and interoperability and how that drove out into each step of the mechanical engineering process. Here's Dave's look at all the tools that they looked at across the different tool categories: manufacturing technologies, analytics, systems, clean tech, and business, and then the different applications that they were evaluating or looking at or using in each of those product categories, and always looking for interoperability and cross-referencing, and looking at how to put together educational partnerships with these various not only software providers but NGOs and consortia developing practical knowledge, research and practical knowledge on each of these vertical topics. So, why does industry care, or why should industry care about sustainability in manufacturing? Certainly a lot of government pressure from regulation, penalties, tax benefits, introduced interest in carbon reduction, certainly scarcity of resources, continuous improvement, external pressures from society, pressures from competition, certainly the innovation and market leadership driver, and ultimately the supply chain effects, really knowing if you're the producer of a finished product, what's happening, where are all of the components and materials you're including in the product, where are they coming from, how are they being made, and what's included in them. And for those of you who are knowledgeable or looking at sustainable purchasing or procurement or supply chain, know that the risk factors lurking in supply chain are significant. Major opportunities in manufacturing, looking at all future systems being based on increasingly precise elements and components, manufacturing for energy environmental awareness, manufacturing for alternate energy supply systems, machine tools that use less natural resources, efficient factory operation, and compliance with government regulations. So very, very broad opportunities for sustainability, maybe say improvements, opportunities to drive innovation through sustainability in manufacturing. Again, looking at a systems approach and applying the definition of sustainability, that it has to work on economic, social, and environmental. All three comprise the definition of sustainability. They've then mapped design and manufacturing to that definition and further connected the very technical attributes of the definition to human needs and desires, and looking more broadly at social impacts. And what's really profound about this approach is not only that we're looking at work that's 3 years old and was already quite well developed and already being executed, but giving engineers a holistic approach to thinking about their contributions to society, and that the impacts of their decisions are not only far-reaching but are enduring. And engineers do feel a special responsibility to making the right decisions and being able to substantiate those decisions. And so this method of teaching and contextualizing is very powerful and really reinforces the pride, if you will, the pride and importance and the value that students are looking to acquire. And that's been something that's really been borne out in research about millennials, is that this is a generation that cares about contribution, that cares about meaning in their jobs, and working for companies that also have meaning and a mission. So this is really preparing students to develop skills to go work in companies where their skills will have the most impact and get the most traction. So Dave always taught the principles of life cycle assessment, in a very structured, technical kind of way, and then applied the LCA process to how it could be used to leverage manufacturing, understanding manufacturing, looking for opportunities for improvement in the manufacturing, product performance improvement, fuel savings, or other consumable savings, and equating those things to overall impact reduction, water reduction, carbon footprint reduction. So really marrying the manufacturing and engineering tenets with LCA and showing how those directly line up, so that technical engineering decisions made throughout the design and implementation process have a direct impact on the environment, and he's drawing these lines quite specifically. He then went through an example of an automotive gear finishing project where he further broke down for his students in an actual engineering project or manufacturing project where, using the terminology of the manufacturing project and the manufacturing metrics, where impacts, direct impacts and indirect impacts and opportunities existed. And then again, this idea of making trade-off decisions, weighing one thing against another, and ultimately being able to make informed trade-offs to reduce impact and create the highest performing products. And across the supply chain. So the only way to teach such an integrated and sophisticated approach is to take a systems approach to understanding a system. And so it was very elegant in the way that that he'd set up the work happening in the lab, and ultimately how that was flowing back out into the chemical engineering curriculum. I'm going to talk a little bit about sustainable mines, and it's always exciting and validating, and particularly when we first did this webcast with Dave, to understand why he was so excited about using sustainable mines, because you'll see how sustainable mines gave Dave and gives the school still a practical way to implement all of the concepts and ideas that Dave developed and others have integrated into curriculum. So our mission as a company, as a software company, is to help product manufacturers operationalize environmental performance into product development and manufacturing for the purpose of driving revenue and growth through greener product innovation. We've never ever talked about, I'm using air quotes now, doing the right thing. It's never been about that. It's been about all of the drivers that Dave walked through: supply chain risk, natural resources, all of the opportunities for new products. And to do that, to really look for the innovation opportunities, what's required first is to get people to think differently. And when we started the company back in 2008, the acronym PLM for that whole category of software products product lifecycle management largely and almost exclusively considered the product lifecycle to be cradle to gate or gate to gate, actually more gate to gate than cradle to gate. So we realized our first challenge was to redefine the PL and PLM to teach product manufacturers that the entire product lifecycle is all the way through end of life, and there's a significant producer responsibility component that needed to be understood. Because once that producer responsibility component is understood, it opens up significant opportunities for innovation and efficiency both in manufacturing and getting to innovative new products. So teaching people to think differently is where the innovation happens. Measuring is not innovative. You know, people say you got to measure what matters, and that's what we're enabling here as well. We have heard, you know, if I had a penny for every time I heard from a student or faculty that they assumed that a decision was going to create some performance improvement, and then when they went to model it, they found out actually no, it didn't, or actually made it worse. You know, I'd have a lot of pennies. I wouldn't be rich, but I'd have a lot of pennies. But it isn't innovative to measure, but it is innovative to measure environmental performance in early stage product development, so that you can actually be making informed trade-offs against criteria that are well understood: functional performance, cost, aesthetic, safety, and now environmental performance also playing a role in the strategy of a product. And so having real data to be able to make those informed trade-offs. When you put those two things together, thinking differently and measuring, you're going to get products that actually are greener. So we talk about environmental performance. So greener is a code word for environmental performance, as it's just another criteria in product development that sits alongside the other product development criteria. You know, this is our slide. Dave said it before we did. You know, we all understand there's real business drivers, real demand on both sides, resource reduction, risk management, and new product innovation and revenues. And you know, deeply understanding that working this way requires new knowledge, processes, and tools. And just a quick aside, since this original webcast with Dave, System Minds has developed another product line called our transparency products, where now that the market is getting more sophisticated in understanding that making random green claims like recycled materials or local sourcing don't necessarily stand up to critical review, that there has become a need for critically reviewed scientific LCA-based marketing tools. And so we applied the same thinking to, well, how do you make that simple and understandable so that manufacturers can actually credibly tell their greener product story to create preference for their credibly greener products that they now can tell understandable stories about. But getting back to our wanting to design greener products, you know, why is it important to do that and be able to have tools in the earliest stages of design? And that's because the 75% of manufacturing costs are committed by the end of concept design. Decisions about material, energy, recyclability, product life cycle, these are all decisions that lock in the environmental performance of a product. So if you don't have insights into the impacts of those decisions early on, once you get into detailed design, it's very expensive and very complicated to go back and revisit those fundamental decisions. You know, you already know what you're making when you're in detailed design, and it's oftentimes too late. to undo or revisit decisions that may be producing significant impacts. So, here's the shift from gate to gate to a full product life cycle, starting from raw material acquisition through end of life, making sure that there's the understanding of transportation, distribution between each stage, and now really teaching people to think about it in early stage design. And so the tools for doing that is eco-design or life cycle thinking, where strategies that can be used to instigate new concepts and at the same time be used to eliminate, reduce, avoid, optimize performance in any life cycle stage can be applied. And so you use those strategies to inspire new thinking, and then you use life cycle assessment to go measure whether or not those ideas, the decisions driven from those ideas, are contributing to performance improvement or an increase in impact. So what we did, and just like what Dave did, integrating manufacturing terminology with life cycle assessment terminology, we did a similar thing, integrating manufacturing or engineering technology with life cycle assessment technology. We coined this term a system bill of materials, because typically a bill of materials is just looking at materials, but to explain how life cycle assessment is the scientific method for evaluating environmental impacts in products and systems. We said, look, you have to look at all the inputs in every life cycle stage, not just materials, which is why we call this the system, the product system bill of materials, because every single one of these inputs can be and is described in chemical data, and when put through the lens of methodology, each of those chemicals can be attributed to one or more categories of impact, and each of those impact categories can be attributed to one or more types of damage, either to human health or to the built environment. And the way that we made LCA, or have made life cycle assessment understandable to non-LCA experts, is to simplify the data and the technical results into a single figure score, but using science and data from all the sources that are used in the explicit high-end LCA products. All we've done is made it simpler so that it can be used to make comparative decisions, both looking at overall impacts across ecological damage, human health damage, and resource depletion, as well as carbon footprint. There are some people who believe that just solving the carbon problem will end up taking care of a bunch of other problems. And so for that purpose, our methodology provides two scores for each input. The impact factor, which is the aggregate of the impacts to each impact category, and then we also take the global warming score and convert that to carbon equivalents. Now, data is the key to everything, and it just so happens that there really is not life cycle inventory data or chemical data that I showed you for all materials and processes that might want to get modeled with. And so we provide the service of helping to source and create data either from other public sources or from supplier-specific or primary manufacturing, or we can also create proxies if there is really no primary data or actual data available. And you're going to see this is exactly the project that Cindy, our intern, and Dave's student worked on. We'll show you at the end how she created a project for students to understand the impacts of modeling with proxy data and how to create a proxy. So this is a pretty fundamental concept that we designed Sustainable Minds to express, that there is no such thing as a green product. All products use materials, they all create waste. Green is a relative value. It can only be about making comparisons. So in the Concepts tab, at the heart of any project done in Sustainable Minds, we're showing the performance improvement or the increase in impacts for any given concept relative to a baseline. So when you start modeling a project, the very first model you build becomes your reference. You can copy that reference, change it up, you can build completely new models, and these results are always relative to this baseline. Now you can change the baseline whenever you like if you've answered your comparative questions. So Sustainable Minds is designed to be very flexible, to be able to allow for very rapid modeling and to answer very simple questions. Maybe it's just comparing a material to another material or a material in a process, all the way through modeling all of the impacts in the product's life cycle. So to summarize, Sustainable Minds' primary use case is to benchmark and compare competing concepts to get quantified estimates of environmental performance. Again, it's for non-experts, to integrate into product development. It was the first cloud-based, standardized system, and still is, for expressly for this use case. And the results are easy to interpret and share to support decisions made in design and manufacturing. And we have a pretty significant learning center, which is the equivalent of about a 150-page textbook on how to use the methodology, eco-design, and LCA. And many of our educators use that to supplement or in place of a textbook in their courses. I'm going to move ahead and dive into our customer story from Margot. And quick bio on Margot. She was a research engineer there at UC Berkeley. She'd worked at the Sustainability Consortium and was a researcher at the lab. There's a question that's come in, and a couple that have come in I'll answer in the meantime. Yes, our customers have used Sustainable Minds on bio-based materials. Any material that we can acquire or create data for can be added to the data set. That is no problem whatsoever. So getting back here to Margot's story, here's the course she taught, and it's a graduate course. The goal is to provide a basis for understanding what comprises a sustainable practice, how to practice and measure continuous improvement, and the techniques for effective communication of sustainability performance. And that's been something that has been really important in a number of our customer stories that educators have talked about. It's not enough just to teach students to think differently and measure. They have to be able to communicate the implications of their decisions and to be able to substantiate why they're making those claims, and it's the right decision to make. Here's the overview of her course. It was a 14-week course, and she broke it down starting with the business case, teaching a lot of the work that David developed about manufacturing and life cycle thinking, and then ultimately gave 3 projects. We're going to cover those. So here's the Sustainable Design for Manufacturing project in weeks 3 or 4, and her objective was to teach the understandability of constraints associated with embodying sustainable design, be able to identify what's required in process design, product design, familiarity with common tools, and the project was to use Sustainable Minds to analyze a simple design, create a reference or a baseline, and evaluate the impact of variation. So real simple, just teaching the fundamentals of integrating lifecycle thinking into design decisions. And so the homework project was simply to use Sustainable Minds to create a more comprehensive example of a product. And it could be any product. And she gave some examples, really a simple product with a very few parts. So here she gave some suggestions about some very simple examples and just asked people to step through the stages of using Sustainable Minds, build the BOM, analyze the results, based on what the results were telling, where the impacts occurring in the product system, develop at least two alternatives. Her grading rubric was very clear, and it was really wonderful that she shared this, because we often get this as a follow-up question. You know, don't just tell me about the project, give me the whole course, you know, because I could use this. And so here's how she broke down her grading rubric. And she even broke it down into the assignment schedule and the days in which it would be completed and what was kind of due each day. So it also included, you know, the informational part, like provide me a slide that shows me what you're doing, and then ultimately submit a report based on the modifications and replacements. So, you know, the report would be the summary of the project, what they learned in the analysis, and using the result screens exported from Sustainable Minds to illustrate those results, which is the exact intended use that we created Sustainable Minds for, to be able to use it in design and use the results to put in design briefs and substantiate decisions. She was really impressed by the range of products that students chose, you know, everything from a pizza box to a Darfur stove. You can see the range. It was very interesting. And so she shared several of the students' results. Here's the hot glue gun. And this slide, the structure of this slide that you're seeing is a format that Sustainable Minds uses to tell any project story, and we provide to the educators to use to tell their own story, because these are kind of the key things you want to learn from having done a project, which is, for this product, what was causing the greatest impacts, what concept did they explore, and describe those concepts. And so the concepts were generated based on the insights of the results. So here's the reference. They were able to understand what in system bill of materials was causing the greatest impacts. There are 6 different results views. This is the scorecard view. But ultimately, it all leads down to the key learnings. What were the key learnings? That connecting design decisions to environmental impacts was possible and easy to do, and that this design for disassembly strategy, that eco-design strategy, and a change in consumer behavior were going to be necessary to implement the final concept. So implementing a design for disassembly strategy is something that the design engineers and manufacturing team can do, but the behavior change is on the shoulders of the marketing department. And so this is really where it's a great example of product development and marketing coming together really early on, which happens in most organizations, but to really think about now the role of product management to figure out if this manufacturer is going to be striving to build a credibly greener brand, then what kind of performance improvements did they really have control over that would be meaningful? And then how do they parlay those into stories and messages that would be meaningful to the consumers that they're targeting? So it really is a kind of comprehensive way of people in organizations thinking differently and then acting differently. And this is why Sustainable Minds is used in every kind of curriculum, business, engineering, and design, because everybody has to be able to think differently from a life cycle perspective and understand what their role is and their particular contribution to driving those decisions forward. So key learnings from the students were that Sustainable Minds is easy to use, that it was easy also because you could view results from a part perspective or a material perspective. Clearly they were able to connect design decisions to environmental impacts. They were able to address trade-offs, and that recognizing that some designs do require a shift in behavior, which is an additional responsibility for manufacturers to take on and convey. But oftentimes it's those innovations that could represent the greatest opportunity for manufacturers to bring game-changing products to market. The key learning for her as an educator, not coming from engineering and not life cycle assessment, is that the functional unit is a concept that bears spending a fair amount of time on, which everybody who's ever looked at LCA knows. The functional unit is a pretty interesting concept, because the functional unit is the unit of service delivered that you're going to decide to measure the impacts with. So if it's 1 year of service, if a light bulb is going to last 1 year, then you're going to measure the functional unit impacts per 1 year of service. But the truth is, what's interesting is when you break down the function of a product to the amount of service delivered, that's actually a sustainability strategy, and it's even a product development strategy, because what it allows you to do is separate form from function. When you think about, for example, the design of a cup or a glass, but you distill it down to, for example, the functional unit being the delivery of 8 ounces of a cold beverage, now the project is wide open to really think about many kinds of forms, not just a cup or a glass, that would meet the requirements of the use cases, but also potentially provide new opportunities for really thinking differently about the solution. So there could be quite a lot of time spent on the functional unit. We do have some teaching tools in the Learning Center to help with that. Of course, she went on to say in the next iteration, challenge students to select and create proxies for data. So if the data isn't available for example, a particular bio-based material, which might be able to be made available, could there be some modeling done with a proxy or an alternative that would get you close to a potential solution? Anyway, it really required students to dig into what the data and what the methodology was explaining. And I'm going to just pick up the pace on the next 2 projects so that we can go into Cindy's proxy creation project, which is really quite innovative. Anyway, getting on into the project, use case 2 was then a semester-long project building on this very simple kind of entry-level project. Now it's a semester-long project, and the goals for this project, the soccer ball project she assigned the product, was to quantify the impacts, determine the life cycle stages where the greatest impact was occurring, compare a standard soccer ball to several other branded soccer balls to see whether, okay, if there's a generic benchmark, how are these manufactured branded products lining up? And this is a very, very standard study that's now just being added to competitive or comparative analysis in manufacturing organizations and design organizations who really are looking to be able to make comparative claims. And then from that deconstruction, identify manufacturing strategies that these folks might have used, and to apply that thinking to how to improve your own new design. And so these are some of the findings, that transportation and end of life contributed to the greatest impacts based on where the balls were manufactured and where they were getting used. They looked at a number of end of life concepts and identified where in each product, in each life cycle stage, what was creating the greatest impact. You can see they called out this particular ball, the capacitor was creating 65% of the impact, which is pretty stunning. Normally you don't see that kind of impact from one ingredient or one input, but it is a simple product. There aren't that many inputs, but nonetheless. And then this insight about the balls being manufactured in Pakistan. And I think the numbers are always a little bit suspect, which is why the substantiation of how the work was done. It's like taking a math test when we were all younger. It wasn't enough to just write the number and get the grade. You had to show your work so that the teacher could understand, did you guess at that number, or was that number derived from a process that made sense? So anyway, then they went on to look at the triple bottom line, the environmental, economic, and social impacts of the baseline relative to the branded products. And ultimately, the key learnings were that 3 different soccer balls could have 3 different triple bottom lines, and that using stale lines enabled them to quantify the environmental trade-offs and to inform design decision making. The third use case is a capstone project, and she talked a fair amount about the goals of their capstone project and the components of that capstone project and the learning outcomes anticipated from a capstone. Improving the bottom line, and so now that's really carried through from the very beginning all the way through to the most intensive and sophisticated projects. And again, breaking it down to a very, very technical level, looking really even at the chemical ingredients of a very simple product like this turbine blade. And the outcome, the learning for educators, was to be able to provide a very structured approach. Now, if you come to some of our webcasts or even watch some of them online, there's a whole range, there's a whole different set of approaches. Some educators use a less structured approach because the software itself and lifecycle assessment is a structure. So it's really just a choice about the style of teaching and how comparative you want the results to be in the course itself. So she valued, obviously, a very highly structured approach, and I think her outcomes were excellent because of that. The learnings from the students were, again, the experience of life cycle thinking, the ability to make trade-offs, and the understanding of the opportunities in design that could affect the outcome of the entire project. Meet Cindy. She was, like I mentioned, our intern for a couple of years while she was at UC Berkeley. And so she became quite proficient with sustainable lines and also with understanding the educational use cases. So she was looking at what's new, what's going to be the next iteration for projects that Margot would teach in her course. So she was one of Margot's students and, of course, one of Dave's students. And so what she was looking at was a series of weekly assignments of varying complexity and takeaways, in the context of the way Margot had structured her course. So in the first use case, which was the simple use case, examining a simple project, she would add an exercise then about understanding NOAA points, the Tracy methodology, and the functional unit. So getting a little bit more of the science into the early, get your feet wet kind of project. And later in the group project, in the 2-week project, being more specific about the alternative concepts to build, and more specificity about the inputs into those alternative concepts, but then leaving it open to, if you're going to use a particular kind of material, then what are the impacts of choosing different processes? So again, following on Margot's observation that delivering a more structured course gets better results, this is integrating more structure into the assignments themselves. And the third one was learning to create proxies and understanding the trade-off, being able to look at different materials, different manufacturing processes, the product lifetime, and the effect of product lifetime on design and the environment. And this can be one whole webcast in and of itself, understanding how today it's most typical that products are overbuilt because they're designed to be more durable and last longer than their marketing cycle or their date of no longer being desirable because the next version is out. I mean, you look at any of the cell phones, the companies want everybody to buy a new cell phone every year, but cell phones, the way they're manufactured and the materials that get used, really can have a lifetime of much longer than a year. So the question then becomes, how do you really think to design to fit with the intended lifetime of the product while still delivering on the required functional performance? So not under designing or under manufacturing to fail early, but to design to be appropriate to the intended lifetime of the product. So here's a project that she developed with telescopic slides. Here's the system bill of materials, and there was industrial grease required. So that's in the system bill of materials, some industrial grease, but there is no data in Sustainable Minds for industrial grease. But there are the components of industrial grease in Sustainable Minds. And so this was to teach students how to actually create a proxy for a finished product by putting together combinations of ingredients. And so she modeled it, and here's a demo of that model. And here's the results of the total impacts by SBOM inputs for that project. And ultimately, these are the questions delivered with the project, the students were to answer to demonstrate they really did get the key learnings out of the project. And you know, the key learnings get delivered alongside the project itself in the software. And what I'm not showing you is that all of the design brief and all of the explanation about the project actually is added to the project, so that from the project page in any student's software, right on the front page of the project is an unlimited amount of information about anything they wanted to include about the project, what was in the design brief, their learnings, concepts discovered. So everything is all there, all in one place, which also supports collaboration. Here are some additional types of projects that she was suggesting. Again, comparative teardowns, analyzing a product that students designed themselves, selecting a product that students suspected of greenwashing and do a teardown, use sustainable minds to refute the theory, or even just a classic comparative problem of paper versus plastic, single versus multi-use. We've seen that project taught multiple times in schools where the educator has assigned a product, coffee cup, disposable versus ceramic, or the paper versus plastic bag. But it's a very common project. Early on, Cindy was very instrumental in reaching out to a number of the educators who had been part of the series, and we put together, we have a curriculum library where the educators have contributed write-ups of anything from the project to the course to in varying degrees of more or less detail, and those are freely available on request for anyone who wants to just do a little review of what other people have done. And so, you know, the summary, Dave's summary of all this at the end is that incorporating sustainability into manufacturing is a requirement, and that the use of measurement to fully understand, to characterize and fully understand manufacturing systems is critical. It's also critical to take a systems approach, looking at all of the criteria used to make decisions about products, and that the holistic approach looks at the role of manufacturing, because remember, manufacturing is just one stage in the product's life cycle. So a sustainable manufacturing curriculum gets those folks well outside thinking of just the manufacturing phase and all the other stages of the product's life cycle. So it's got to be incorporated into not just education, but manufacturing. You need new tools, and these tools are part of a larger framework, as he showed earlier, which is really defining the problem, the scope and boundary, how you're going to measure it, and then the right tools to assess. Preparing students for industry is critical, teaching them ethics, challenging them. No reason why this shouldn't be integrated in undergraduate thinking, because at this point in 2013 it was only in the graduate school. And the need for more projects to be structured, more introductory material, more data to go with those projects. So we do that all the time. An educator will say, I want to do this project, it's this product, I'm going to need this data to support it. So we sell a data package along with the educator subscription and student subscriptions to prepare for just that. So you really can deliver a very tailored project. And by the way, this can also be the identical experience in industry, because all of the folks in industry need upskilling. And so being able to do exactly this kind of thing is what we do in industry. And ultimately how industry observes Berkeley is, it's an institution that's providing a very broad-based curriculum and are creating students that they want to hire. And the tiered explicitness of the projects is, just a standard way of teaching anybody anything, right? Start simple and work up. But by getting a student to do that work well through a capstone project really demonstrates their readiness to take the skills and knowledge into industry. So it's all about jobs in the economy. Dave's story, reinforced by his educator and his students, bore it out beautifully and really aligned and complemented our story in a way that I couldn't have been more thrilled to present. We do have a 7-day free trial for folks to try it out, see if it's going to work for them. We have special education pricing. So industry pricing, it's $1,400 per user annually. In education, an annual subscription for an educator is $350, and it's $49 for an individual student. We have quantity discount pricing for classes, departments, and schools. Again, as schools decide, yes, more of our students, more of our educators need to be integrating this into the way they teach, and we make it increasingly possible and affordable for them to do that. So we've reached the end of our time together, and I do appreciate those of you who have stayed the entire time, which is in fact everyone. And we are really looking forward to connecting with those of you who are integrating sustainability into your curriculum and would like to learn more about Sustainable Minds. You can leave us some comments on your way out of the webcast. Reach out to us, or we will certainly follow up with you as well. So once again, thank you so much for spending time with us today, and go out and have a great day. Thank you.